Okay, so I want to go over a few more examples from your sheet. Probably we're just going to do all of them together, and then I'm going to have some extra ones for you to do. So let's look at number 2. Number 2 is different because it just has one variable in it. But all we're going to do right now is rewrite it in quadratic form. Okay, so I can divide this 6 by 2. So I'd have 16 x to the third squared minus 625, and that's in quadratic form, because really what this is a difference of two squares. We have 16, which is a perfect square. This x to the third is a perfect square. This 625 is a perfect square. Actually, if I wanted to write it using the square root of the coefficients and the constant as well, it would look like this. You'd have 4x to the third squared minus 25 squared. So it is a difference of two squares. And to factor that, it factors into a pair of conjugates. You guys remember conjugates? You have the same terms in both binomials. It's just that one binomial is minus, the other binomial is plus. And that's how you break down a difference of two squares. Take the square root of both terms. Okay, so let's look at number 5. So number 5 ought to be a little bit easier since we did number 2. You have a variable, one variable, and the other one is just a constant. So I can divide this variable by 2, or the exponent, excuse me. So I'm going to have 7 times x to the 5th squared plus 6, and that is written in quadratic form. I can't factor it though. There's nothing I can do to break that down anymore. So for this one, if they wanted you to factor it, you would just say that it's prime. Okay, let's look at number 3. Number 3 is a little bit tricky. And these fraction exponents, those are called rational exponents, and we are not going to work with them yet. We're going to work with them in chapter 6, just so you know what they are. Anyway, so to rewrite this in quadratic form, I need to look at my middle exponent. My first exponent is 1. It's not written, it's understood to be a 1. And 1/2 is half of 1, so I can rewrite this in quadratic form. So when I divide this exponent by 2, it's 1/2 squared minus 9 times x to the 1/2 plus 8. Okay, so when I square that 1/2, remember when you raise a power to a power, you multiply them together, and 1/2 times 2 is going to be 2 over 2, so that would give you back the exponent that we had in the beginning. And let's go ahead and factor this. It can factor. My leading coefficient is 1, so I'm just going to look at the constant of positive 8. 2 factors of positive 8 that add to be a negative 9. It's going to be negative 8 and negative 1. So I'm going to rewrite it. X to the 1/2 squared minus 1 x to the 1/2. You don't have to have that coefficient of 1. I'm just trying to make a point there, so it's fine if you don't. Minus 8 x to the 1/2 plus 8. Okay, so I'm going to group my first two terms, group my second two terms. The first two terms have an x to the 1/2 in common. I'm going to take that out. So I'm left with this first term. I had 2 x to the 1/2, so I still have 1. And my second term, I just have a 1 left. My next two terms, I'm going to take out a negative 8. So I'll have x to the 1/2 minus 1 inside the parentheses again there. So I can finish that by consolidating the x to the 1/2 minus 8 and writing that x to the 1/2 minus 1 one time, and that would be your factors for that polynomial. Okay, so in this section we're going to be factoring all kinds of polynomials. We have already factored, you guys are used to the difference of two squares. I'm going to abbreviate here. And that's going to factor into a pair of conjugates, a minus b times a plus b, where a and b is the square root. You know, it's just your a and just your b. Okay, but we're also going to learn how to factor a difference of two cubes. And there is a pattern for a difference of two cubes. Okay, you find the cube root of your first term, cube root of your second term. So that would be a, that would be b, and it's going to break down to a binomial times a trinomial. So when you take the square root of a, square root of b, you have a minus b, and then you square the a, multiply a and b together, square the b. So let's do just a little example. X to the third minus 8. My first term is a perfect cube, and 8 is actually a perfect cube. This is 2 to the third power. So you have to find the cube root of both terms. The cube root of x to the third is x. Cube root of 8 is 2. So my a is x, and b is 2. And I just am going to follow this pattern to factor it. Okay, so that's going to factor to a is x minus b is 2. Okay, so that's my binomial. Now I need to square the a, so that's x squared. And I don't worry about the sign, it's just the cube root of each term, like the absolute value of those terms. Okay, so I'm going to take a times b, so that's going to be 2x. And then I need to square the b. B is 2, so that's going to be 4. And there you have your factors. This trinomial, you can never factor again. It's always going to be prime. So as you know, that's as far as you can go with the difference of two cubes. Okay, so I'm going to show you a sum of two cubes, which is very similar, of course, but they're being added together instead of being subtracted together. So you're going to have to be able to recognize if your terms are perfect cubes or not. You're going to have to start thinking about that whenever you see a problem that they're telling you to factor. So a sum of two cubes will factor into, that pattern is a plus b, a squared minus ab plus b squared. So if you look at the factors for a difference and the factors for a sum, it's very similar pattern. It's just that the plus and the minus are in different spots. You only have one negative. It doesn't matter what it is, if it's an addition problem or subtraction. You just have one negative. It just matters where the placement is. Okay, so let's do an example for a sum of two cubes. And I'm going to use just a z to the third plus 125. Okay, z to the third is a perfect cube. The cube root is z. 125 is a perfect cube. The cube root is 5. Okay, so let's break it down using the pattern. So a is z, b is 5, and it doesn't matter the signs. We're just going to follow this pattern. We're just putting the numbers in, the variables in. Okay, so a is z, and it's plus b. A squared is going to be z squared. A times b is 5z, and then b squared is 25, and those are your factors. The trinomial is always prime. You can't break it down. Okay, so tomorrow in class, I'm going to have a worksheet for you to do of factoring. It's just going to be quadratics, though. I'm not going to give you any sum or difference of cubes because I want to go over it again with you in class. But this is going to be a start for you. You'll have it kind of in your brain, and we'll talk about it some more on Wednesday. I'm not going to be in school tomorrow. You have the assembly, and we're just going to be really busy. So I'll have a worksheet for you to do on quadratics, factoring quadratics, and I'll see you guys on Wednesday. Hope you have a good day. Bye.